Okay, so in this video, I'm going to show you how to take an equation like this, and instead of writing it as an equation explicitly relating variables x and y, I'm going to show you how to write it as a function transformation. So first, the first step on how to write this as a function transformation is first to identify what kind of function this is and write the simplest version of that function. So here, this is clearly a quadratic function, right? If we expand this binomial here, we're going to get an x squared term. That's going to be the highest degree term. It will be a degree 2 polynomial. That's a quadratic. So what is the simplest form of a quadratic function? Well, the simplest form of a quadratic function is x squared. We can call this function f. So here we have function f. It is a function of x, meaning the input goes into this x variable here. And there you go. So we have this originally defined function, and now we want to write this as as a transformation of this function. So we want the curve that's created by this equation, but we want to write it in a different notation. So we can simply write y equals f of x, but we're going to have to plug in some parameters here, right? Because if we just graph y equals f of x, then we're just going to get x squared. So what parameters could we plug in to transform this simple function into this more complicated function, but in function notation with parameters? Well, what we can notice here is that we have 0.49 times x minus 26.8 squared. So this is going to be our a value. It's our a parameter, right? It shows us how much we're stretching or compressing. In this particular case, it's going to be a compression, so 0.49 times your function. And then for our input, it looks like before we're squaring our input here, so here for f of x equals x squared, whatever our input is, we square the input. So what are we squaring here? We're squaring x minus 26.8. So before that's squared, we have to subtract 26.8 first. So x minus 26.8, that's going to be our c value. It's really going to represent a shift of 26.8 units to the right. And then we have this addition of 35.89, and that's after everything is all said and done, right? So like you subtract 26.8 directly from the input before it's even squared, so that's your c value. And then after you square it, after you apply that function rule, that function rule which says square your input, after you square it, you'll multiply it by 0.49, which shrinks it, right? So that's your a value. And then after you do all that, so after you deal with your c value and your a value, we're going to add 35.89 to whatever that result is. So whatever that result is, we add 35.89. What that does to your curve, the graph of your curve, is it shifts it up by 35.89 units. So that's really your d value. All right, so this is what this is essentially what I'm looking for. So here we have some the graph of some function in function notation, and we've applied transformation parameters to that original function. I'll show you what that looks like when we input it into Desmos. So if we're to input this into Desmos, let's change to laptop mode here. So let's go to Desmos. So here is the original function written explicitly in terms of relating variables x and y. But let's try to match this. So first, I'm just going to define some new simple version. What's the simplest version of this type of function? Well, this is a quadratic function. Simplest quadratic function is x squared. But I don't want this to show up on my graph, right? I just want to define this as some original function f of x. So I won't allow it to be seen on my graph. So I click that circle. Now it's gone. Now I want to write an equation in function notation with transformation parameters that will graph the same curve as this equation. So I'll just write y equals f of x. and I'll introduce those same transformation parameters, right? What are we doing to our input before we square it, before we apply our function rule? We are subtracting 26.8. What are we doing after we apply our function rule? Well, we're multiplying it by 0.49. What are we doing after we multiply that result by 0.49? Well, we're adding 35.89, so plus 35.89. And we can see that this green graph matches the red graph, right? They lie all along the same points. So what we can do is we can say this is a successful rewording or a successful way of representing this same relationship between inputs and outputs, but just in function notation with transformation parameters introduced, rather than just written as a relationship between x and y. And the reason I want you to write it more like this is just to show the learning of the concepts taught in Chapter 2. So there you go. Hopefully that makes a little bit of sense. This is ultimately what I'd want to see. And again, whatever your original function, whatever your original basic function is, you can just click this circle here so it doesn't show up, and all that shows up is the curve that you want. So there you go.